So as I've written here, I've written limit as x approaches 2, x squared. And what this means is that as we get x as close as we can to 2, what does x squared approach? And we can't just think about as x goes from 0 to 1 to 2, which means like from the left side. We also have to think about what it approaches from the right side. So like 5 to 4 and then to 3. So for this one, this is pretty easy because you can just plug in 2 for this. 2 squared equals 4. But for some functions, you can't plug in the value of what x approaches. And we shouldn't think about it that way either, because it's not about what the value is, but it's what the value approaches or should be. So for example, for this one, this is just pretty easy. It's not a good example for what I'm talking about. So let's say this is 2, and then right here, this is 4. And as x approaches 2 from the left side and from the right side, it goes to the y value of 4. So we say all this is equal to 4. And that's how we evaluate the limit for this. So here's an example of a limit that I was talking about where you can't just plug in the value that x approaches into the function. So for here, we're trying to figure out the limit of 5x plus x squared over x as x approaches 0 from both sides. So if you plug in 0 for x, we get 5 times 0 plus 0 squared over 0. And this just equals 0 over 0, which is like undefined, so we can't just do this. We have to find out what the limit is. But I noticed that we can factor out an x from both the 5x and the x squared on the top. So you can do x times 5 plus x over x. And look, these x's cancel out. So we're left with 5 plus x. And 5 plus x is the same as 5x plus x squared over x. It's the same function, except we got rid of the place where we can't plug in 0. So now we can plug in 0, and we get 5 plus 0, which is just 5. So the limit of 5x plus x squared over x as x approaches 0 is 5. And this is how you can manipulate the function in one way to be able to substitute what x approaches into the function. Now, let's do some examples. If we want to find the limit of 5x squared minus 3x plus 2 as x approaches 2, well, for this one, we can just plug in 2 into the function 5x squared plus minus 3x plus 2. So let's just do that. So 5 times 2 squared minus 3 times 2 plus 2. And this is just 16, pretty easy. And for this one, it was simple because we were able to plug in the value that x approaches into this, but that's not going to work for all of them. For every function you get, don't just blindly put in the x value into the function. You have to think about it first. Is it going to work or not? Now let's get into another example. Problems. So for this one, we want to evaluate the limit of x squared minus 2x. This problem asks to evaluate the limit of 5 minus x 2x approaches 2 as x approaches -1. And you can probably already tell why just by thinking of it. There's no real reason where x for 2 substitution would not work, because if we substitute 2 in the denominator, it equals -1 for x in this function. So that's undefined. So it's just 5 minus 2. Just like the one I showed earlier, because we can factor out an x in the numerator equal to, we get 5 plus x2 times x equals 2, 7. And that's our answer. So it's pretty easy. 2. So the limit, and this works out well, 5 minus 2x as x approaches -1 cancel out sides x minus is equal to 7. Both the numerator and the denominator. Now, let's get into some practice problems with x. If you think you know how to do this one, this is pretty easy. Now we can just substitute 2 in for x. This problem asks to evaluate the limit of 5 minus 2x as the limit approaches -1. X squared minus 2x all over and x just by thinking of it, there's no real reason where 2. Now, let's get into some practice problems. If you think you know how to do this one, then pause the video and try it. This problem asks to evaluate the limit of 5 minus 2x as x approaches -1. And just by thinking of it, there's no real reason where substitution would not work. So let's just substitute -1 for x in this function. So it's just 5 minus 2 times -1, because that's what we're calculating, is equal to 5 plus 2 equals 7. And that's our answer, so it's pretty easy. So the limit of 5 minus 2x as x approaches -1 from both sides is equal to 7. Now, let's get into another practice problem. If you think you know to do this one, then pause the video and do it. This problem asks to evaluate the limit of x squared minus x minus 6 all over x minus 3 as x approaches 3. So you can probably already see that we can't substitute 3 for x, because if we do that, the denominator ends up as 0 because it's 3 minus 3, and that's not good. We want to end up with a number as an answer if we can. So I can notice that the numerator is a quadratic, so let's try to factor that and see what we can do. So you get x minus 3, x plus 2. That's what the factor form is, all over x minus 3. And this works out well because we can factor out the x minus 3 from both sides, and we're left with x plus 2. And now we can substitute 3 for x because there's nothing that could go wrong. Like if we substitute 3 in the original function, we get undefined, but not here. So we get 3 plus 2 is equal to 5, and that's our answer. So the limit of x squared minus x minus 6 all over x minus 3 as x approaches 3 is 5. Now, let's do one last practice problem. If you think you know to do this one, then pause the video and do it. This one asks to evaluate the limit of x over x as x approaches 0. And for this one, again, we can't just plug in 0 for x because then we're left with 0 over 0, which is undefined, and that's not good. And for this one, there's nothing really we can factor out the numerator or denominator, but we kind of skip that step because we notice that x over x, that's just 1. So we can rewrite this as limit x approaches 0 of 1. And since there's no x in the equation, we can ignore whatever x approaches since it's always going to equal 1. And since there's values both from the left side and the right side of 0, there's just a whole at 0, then what we can do is just say this is equal to 1. So the limit of x over x as x approaches 0 is 1. So everything I explained in this video and all the problems that I went through should teach you everything that you need to know about limits and how to get started with calculating them. If you learned something from this video, or if you enjoyed it, then please consider liking and subscribing.